this lesson today, we're going to talk about linear programming. Sometimes decision-making in management science requires that we find a minimum or a maximum of a linear function. Now that f is our function here, a sub 1 x sub 1 plus a sub 2 x sub 2 plus all the way up through a sub n x sub n. That's called an objection function over a set of points. Such a problem is a linear programming problem. In 2 dimensions, the function of f takes the form of f equals ax plus by, and the set of points is a solution of a system of inequalities called constraints, such as the one in example 5. The solution of the system of inequalities is the set of feasible xy points for the optimization problem. So really what we're going to be doing, we're going to be finding the intersection points of our problem and finding where they intersect here. It can be shown that if a linear programming problem has a solution, it occurs at one of the vertex points or corner points along the boundary of the region. We use this information in examples 6 and 7. Now in example 6, it says find the maximum and minimum values of the objection function 5x plus 8y, subject to the constraints given by the system of inequalities. So first we're going to have to do are to solve these equations for y. So in this one here, it should be nice and easy. Y equals negative 2x plus 10 is our boundary function, so it's going to be y is less than or equal to negative 2x plus 10. This one here is 3y is less than or equal to negative 2x plus 14, which means y is less than or equal to negative 2/3 x plus 14/3. This is just like our example in number 5. So what we're going to do, we're actually going to put this into our calculator. So I have negative 2x plus 10. We'll have negative 2x divided by 3 for negative 2/3 x plus 14 divided by 3. And then it also says x is greater than or equal to 0, y is greater than or equal to 0. So what we can do, our x min can be 0. X max, we can make that 10. Because if x is 0, y would be 10 here. And if y was 0, x would be, let's say, 5 or 10. So we can just make that there. X scale would be 1. We go 0 to 10 again and make that 1. So when we graph this, this is what we're going to have. Something that looks just like this. Now, what we need to do, we need to find our corner points. Well, our region will look like this. I'll take a picture of it so we can draw on. So the region that we're talking about here is right here. I'll color it in green. This is the region that we're talking about here. Okay? X is greater than 0, y is greater than 0. It's less than our 2 equations. So what we need to do, we need to find this point here, this point, and this point. So our corners, they should be pretty easy. One we have at 0, 0. Another one we have at our y-intercept. Our y-intercept happens where x is 0. So that will be actually at 14/3 and 0. So 0 and 14/3. We'll have another one at our x-intercept. Our x-intercept happens where y is 0. In this case here, it's going to be 5. And then we're also going to have to find that intersection point there. So we're going to go back to our calculator and find our intersection point. So we're going to find the intersection point of this line and this line. So intersection point is at 4, 2. What we're going to have to do now, we're going to find the maximum and minimum values. So what we're going to do, we're going to use the 5x plus 8y. If we use 5x plus 8y, our x is 0, y is 0, so my values will be here, my value will be 0 here. And then we'll do 0, and then 8 times 14 thirds. So we're going to take 8 times 14 divided by 3. This is 37 1/3. I'm going to have 5 times 0, or 5 zeros, so 5 is x, 0 is y. 5 times 5 is 25. And then we're also going to have 5 times 4 is 20, and 8 times 2 is 16, so we have 36 for a value here. So, what is my maximum, what is my minimum? Well, I'll have a max value of 37 1/3 at the point 0, 14 thirds. Min value of 0 at 0, 0. Now this will make a little bit more sense once we get into example 6 and 7, or example 7. When we're trying to find actual parts to a problem, it'll make a lot more sense. Now moving on to B, we're pretty much doing the same thing here. We have y is less than or equal to negative x plus 80. Negative 2y is less than or equal to negative x. Now remember, when you divide by a negative, it's going to flip your inequality. So that's what we're going to have there. So when we do this, we're going to put these equations into our calculator. We have negative x plus 80, 0.5x, and then x is greater or equal to 0, y is greater than or equal to 0. We change our window. If x is 0, y will be 80, so make our y max 100. If y is 0, x again will be 80, so make that 100. So make our window that. So there's our part. So where is this greater than or equal to 0? So here's what we're going to have. It says y is greater than or equal to 1/2. So let's take a picture of it to actually draw what our boundary region is going to look like here. So where is it less than 80? We're actually going to go this way. Where is it greater than 1/2? We're going to go this way. So if you can tell, this is the region that we're looking at here. This is our region that we're trying to find. So when we do this, we have to find these points. We have to find this point here, our y-intercept. Our y-intercept happens when x is 0, so that will be 80. So this here point will be 0 and 80. This point here will be 0, 0. We also have to find this point here. So what we're going to do to find that point, we got to find the intersection point. So let's find our intersection. 53 1/3 and 26 2/3. So there's our corners. It's 0, 80, 0, 0, 53 1/3, 26 2/3. So those are our zeros. Now we need to find values for these. So our objective function is 4x plus 3y. 4 times 0 is 0. 80 times 3 is 240. This one will be 0. And then we're going to take 53 1/3 and 26 2/3 and put it in there. So let's actually do that. Let's make these improper fractions first. So 160 over 3 and 26 2/3. Let's make that an improper fraction. So take 160 over 3 times 4 and 3 times 80 over 3. Add those together, you get an answer of 880 over 3. We change it to a decimal, you get 293 and a third. So there's our values. If you look then, our maximum, we'll have a max value of 293 and a third at 53 and a third, 26 and 2/3. We'll also have a minimum of 0 at 0, 0. So again, the biggest thing you have to do in these problems, you have to find the region in which we're trying to shape.